There are several electrical issues that need to be addressed in recently installed receptacles. Firstly, the insufficient wire length in the electrical boxes violates the National Electrical Code, which requires sufficient wire length for easy removal of electrical devices for maintenance and repairs. The inability to remove receptacles for repair poses a safety hazard and makes troubleshooting and repairs difficult. Secondly, the electrical contractor failed to properly bond equipment grounds to the electrical box. This is a serious electrical hazard as it compromises the integrity of the grounding system, which is essential for protecting against electrical shock. Self-grounding clips on receptacles are not a substitute for proper grounding. To repair insufficient wire length, contact the electrical contractor and request that they rectify the issue. If necessary, hire a licensed electrician to extend the wiring in the electrical boxes to meet code requirements. To establish equipment ground bonding, identify the grounding wire, typically green or bare copper, and connect it to the ground screw or terminal in the electrical box. Ensure all electrical devices, including receptacles, are properly grounded to the box. Verify if the electrical contractor has an active warranty for the work performed. If so, they may be liable for the repair costs. Report the issue to the supervisor and request guidance on how to proceed. Notify residents about the safety hazard and take appropriate steps to mitigate the risk, such as turning off affected circuits or placing warning signs. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It's important for electrical work to adhere to the NEC to ensure safety and prevent electrical hazards. Insufficient wire length in electrical boxes is a common violation of the NEC. The code requires enough wire length to allow for easy removal and replacement of devices like receptacles and switches. This is crucial for maintenance and repairs, as it allows electricians to work on the devices without straining or damaging the wires. When there is not enough wire, it can make it difficult to properly connect or disconnect the wires, potentially leading to loose connections or damaged insulation. Improper grounding is another serious electrical hazard. The grounding system is designed to provide a path for fault current to flow back to the source, which trips the circuit breaker or fuse and cuts off power to the circuit. This helps to prevent electrical shock and fire hazards. When equipment is not properly grounded, it can create a dangerous situation where a person could come into contact with a live wire and receive an electrical shock. Self-grounding clips are not a substitute for proper grounding. These clips are designed to provide a grounding path between the receptacle and the metal electrical box. However, they are not always reliable and can become loose or corroded over time. It is always best to properly ground the equipment by connecting the grounding wire to the ground screw or terminal in the electrical box. When repairing electrical wiring, it is important to follow all safety precautions. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. When extending wiring in electrical boxes, be sure to use the correct size and type of wire. The wire should be rated for the voltage and amperage of the circuit. It is also important to make sure that all connections are tight and secure. Loose connections can cause overheating and create a fire hazard. When connecting the grounding wire to the ground screw or terminal in the electrical box, be sure to tighten the screw securely. The grounding wire should be making good contact with the metal of the box. If the electrical box is not grounded, it is important to ground it. This can be done by connecting a grounding wire to the box and then connecting the other end of the wire to a grounding electrode, such as a ground rod or water pipe. It is also important to verify that the electrical contractor has an active warranty for the work performed. If so, they may be liable for the repair costs. The supervisor should be notified about the issue and request guidance on how to proceed. Residents should be notified about the safety hazard and take appropriate steps to mitigate the risk, such as turning off affected circuits or placing warning signs. Electrical safety is a serious matter and should not be taken lightly. By following the NEC and taking appropriate safety precautions, one can help to prevent electrical hazards and protect themselves and others from electrical shock and fire. When working with electrical systems, it is essential to understand the fundamentals of grounding and bonding. These concepts are critical for ensuring safety and preventing electrical hazards. Grounding refers to the connection of electrical equipment or circuits to the earth. This connection provides a low impedance path for fault currents to flow back to the source, which in turn causes the overcurrent protection device, such as a circuit breaker or fuse, to trip and energize the circuit. The purpose of grounding is to limit the voltage on electrical equipment and prevent electrical shock hazards. Bonding, on the other hand, refers to the connection of metallic parts of an electrical system to create an electrically conductive path. This path ensures that all metallic parts are at the same electrical potential, which minimizes the risk of electrical shock if a fault occurs. Bonding is typically achieved by using bonding jumpers or conductors to connect metallic enclosures, conduits, and equipment together. The NEC provides specific requirements for grounding and bonding electrical systems. These requirements are designed to ensure that the grounding and bonding systems are effective in protecting people and property from electrical hazards. One of the key requirements is the use of a grounding electrode system, which consists of one or more grounding electrodes that are connected to the earth. Common grounding electrodes include ground rods, ground plates, and metal water pipes. The NEC also requires that all metallic enclosures and equipment be bonded together using bonding jumpers or conductors. These bonding jumpers must be sized appropriately to handle the fault current that could flow through them. In addition to the general requirements for grounding and bonding, the NEC also provides specific requirements for grounding and bonding different types of electrical equipment. For example, there are specific requirements for grounding and bonding transformers, generators, motors, and other types of equipment. It is important to follow these specific requirements to ensure that the equipment is properly grounded and bonded. When inspecting electrical systems, it is important to check the grounding and bonding systems to ensure that they are installed correctly and are in good condition. This includes checking the grounding electrode system to make sure that it is properly connected to the earth and that the grounding electrodes are in good condition. It also includes checking the bonding jumpers and conductors to make sure that they are properly sized and are securely connected. If any problems are found with the grounding or bonding systems, they should be corrected immediately. Ignoring grounding or bonding issues can create a serious electrical hazard. It is also important to understand the difference between grounding and bonding. Grounding is the connection of electrical equipment or circuits to the earth, while bonding is the connection of metallic parts of an electrical system to create an electrically conductive path. Both grounding and bonding are important for electrical safety, but they serve different purposes. Grounding is intended to limit the voltage on electrical equipment and prevent electrical shock hazards, while bonding is intended to ensure that all metallic parts are at the same electrical potential and minimize the risk of electrical shock if a fault occurs. In summary, grounding and bonding are critical concepts for ensuring electrical safety. By understanding these concepts and following the NEC requirements for grounding and bonding, electrical hazards can be minimized and the safety of people and property can be protected. It is also very important to know the equipment grounding conductor, which is the conductor used to connect the non-current carrying metal parts of equipment, raceways, and other enclosures to the system grounded conductor, the grounding electrode conductor, or both, at the service equipment or at the source of a separately derived system. The purpose of the equipment grounding conductor is to provide a low impedance path for fault current to flow back to the source, which causes the overcurrent protection device to trip and energize the circuit. The equipment grounding conductor is typically a green or bare copper wire. It is important to note that the equipment grounding conductor is not the same as the grounded conductor, which is the conductor that is intentionally grounded. The grounded conductor is typically a white or grey wire. The equipment grounding conductor must be sized according to the NEC. The size of the equipment grounding conductor depends on the size of the overcurrent protection device protecting the circuit. The NEC provides tables that specify the minimum size of the equipment grounding conductor for different size overcurrent protection devices. The equipment grounding conductor must be connected to the equipment grounding terminal on the equipment. The equipment grounding terminal is typically a green or bare metal screw or lug. The equipment grounding conductor must also be connected to the grounding electrode system. The grounding electrode system is the system of electrodes that are used to connect the electrical system to the earth. The grounding electrode system typically consists of one or more ground rods, ground plates, or metal water pipes. The equipment grounding conductor must be connected to the grounding electrode system at the service equipment or at the source of a separately derived system. Separately derived systems include generators, transformers, and other sources of power that are not directly connected to the utility power grid. In addition to the equipment grounding conductor, there is also the bonding conductor. The bonding conductor is used to connect the non-current carrying metal parts of equipment, raceways, and other enclosures together. The purpose of the bonding conductor is to ensure that all of these metal parts are at the same electrical potential. This helps to prevent electrical shock hazards. The bonding conductor is typically a copper wire or strap. The bonding conductor must be sized according to the NEC. The size of the bonding conductor depends on the size of the largest ungrounded conductor in the circuit. The bonding conductor must be connected to the bonding terminal on the equipment. The bonding terminal is typically a metal screw or lug. The bonding conductor must also be connected to the grounding electrode system. The NEC provides specific requirements for grounding and bonding different types of equipment. For example, there are specific requirements for grounding and bonding electrical panels, motors, and appliances. It is important to follow these specific requirements to ensure that the equipment is properly grounded and bonded. When inspecting electrical systems, it is important to check the equipment grounding conductor and the bonding conductor to ensure that they are properly sized, connected, and in good condition. Any problems found with the equipment grounding conductor or the bonding conductor should be corrected immediately. Ignoring grounding or bonding issues can create a serious electrical hazard. It is also important to remember that grounding and bonding are not the same thing. Grounding is the connection of the electrical system to the earth, while bonding is the connection of the non-current carrying metal parts of equipment together. Both grounding and bonding are important for electrical safety. By understanding the purpose of grounding and bonding and by following the NEC requirements for grounding and bonding, the risk of electrical shock and other electrical hazards can be reduced. When dealing with electrical receptacles, it's also critical to understand the concept of receptacle spacing. The NEC specifies requirements for the placement of receptacles in dwelling units to ensure convenient access to electrical power. The general rule is that receptacles should be installed so that no point along the floor line of any wall space is more than 6 feet, or 1.8 meters, from a receptacle. This means that receptacles should be spaced no more than 12 feet, or 3.7 meters, apart. This requirement is intended to minimize the use of extension cords, which can be a safety hazard. The NEC also specifies requirements for receptacle placement in specific areas of dwelling units such as kitchens, bathrooms, and hallways. In kitchens, receptacles must be installed at each countertop wall space that is 12 inches, or 300 millimeters, or wider. Receptacles must also be installed at each island countertop space and each peninsula countertop space that is 24 inches, or 600 millimeters, or wider. These requirements are intended to provide convenient access to electrical power for appliances and other kitchen equipment. In bathrooms, receptacles must be installed within 3 feet, or 900 millimeters, of the outside edge of each basin. The receptacle must be GFCI protected. This requirement is intended to protect people from electrical shock while using electrical appliances in the bathroom. In hallways, receptacles must be installed so that no point along the floor line of the hallway is more than 10 feet, or 3 meters, from a receptacle. This requirement is intended to provide convenient access to electrical power for lighting and other hallway appliances. In addition to the general receptacle spacing requirements, the NEC also specifies requirements for receptacle height. Receptacles must be installed at least 12 inches, or 300 millimeters, above the floor. This requirement is intended to protect receptacles from damage and to make them more accessible to people with disabilities. When installing receptacles, it is important to follow the NEC requirements for receptacle spacing and height. Failure to do so can result in code violations and safety hazards. It is also important to use the correct type of receptacle for the application. For example, GFCI protected receptacles must be used in bathrooms and other wet locations. The NEC is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. By following the NEC requirements for receptacle spacing and height, electrical safety can be improved and the risk of electrical shock and other electrical hazards can be reduced. It is also important to remember that electrical work should only be performed by qualified individuals. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Moreover, when dealing with electrical boxes, several factors must be considered to ensure safety and compliance with the NEC. These factors include box fill calculations, box size, and box type. Box fill calculations are used to determine the maximum number of conductors, devices, and fittings that can be installed in an electrical box. The NEC provides specific rules for calculating box fill. These rules take into account the size of the conductors, the number of devices, and the volume of the box. It is important to perform box fill calculations before installing any wiring in an electrical box to ensure that the box is not overcrowded. An overcrowded electrical box can overheat and create a fire hazard. Box size is another important factor to consider when selecting electrical boxes. The NEC specifies minimum box sizes for different applications. The size of the box depends on the number of conductors, devices, and fittings that will be installed in the box. It is important to select a box that is large enough to accommodate all of the wiring and devices without overcrowding the box. Box type is also an important factor to consider when selecting electrical boxes. There are different types of electrical boxes available for different applications. For example, metal boxes are typically used for surface-mounted wiring, while non-metallic boxes are typically used for recessed wiring. It is important to select the correct type of box for the application. In addition to the factors mentioned above, there are also several other things to keep in mind when working with electrical boxes. For example, all electrical boxes must be properly grounded. This can be done by connecting a grounding wire to the box and then connecting the grounding wire to the grounding electrode system. All electrical boxes must also be securely mounted. This can be done by using screws, nails, or other approved fasteners. All electrical boxes must be accessible. This means that the box must be located in a place where it can be easily reached for inspection and maintenance. It is also important to follow all local electrical codes when working with electrical boxes. Local electrical codes may have additional requirements that are not covered by the NEC. By following these guidelines, it is possible to ensure that electrical boxes are installed safely and in compliance with the NEC. This will help to protect people and property from electrical hazards.